Welcome to this lesson on circles and spheres. We are going to talk about the area of circles and the surface area and volume of a sphere. In order to find the area of a circle, we use the formula area equals pi times r squared, with r of course being the radius. In example 1, we are asked to find the area of a round fountain with a radius of 6 feet. In order to do that, I'll use my area formula and I will replace r with 6. So I'm going to substitute and get area equals pi times 6 squared, which gives me 36 pi. If I plug that into a calculator, I will find that the area will equal 113.1 feet. Remember that area is a unit that is always squared. So I am measuring square feet, so my area is 113.1 feet squared. In example 2, I'm asked to find the area of a round table with a diameter of 7 feet. Remember, if they give you the diameter and your formula asks for the radius, you need to find r as the diameter divided by 2. So in this particular case, my r is 3.5. So I'm going to substitute the radius into my formula. Area equals pi times 3.5 squared. And that comes out to be an area of 38.5 feet squared. These are common types of problems which you would be asked to solve regarding the area of a circle. A practical problem is given in example 3. If you were given 25 square feet of patio tiles, so this means you are given a certain amount of material in square feet. What is the radius of the largest round patio that you could build with these tiles? So I'm going to again use my formula for the area of a circle, but this time I know the area and I need to find the radius. So I'm going to substitute 25 for area. That equals pi times r squared. In order to solve for r, I'm going to divide both sides by pi, and that would give me 7.95 equals r squared. R squared is nice, but I need just the radius, not the radius squared. So you may recall that the way you find the square root of a squared number is that you have to take the square root of both sides. So I'm going to find the square root of 7.95 because that equals the square root of r squared. In doing so, I find that r equals 2.8 feet. Notice my units are no longer squared because radius is a linear measurement. So this would be the length of the largest possible radius, given that I have 25 square feet of patio tiles to work with. We're going to move on and talk about the surface area and the volume of spheres. A sphere, remember, is the set of all points that are a given distance from a given point. So a circle is the set of all points a given distance from a center, and it's two-dimensional. A sphere is very similar in that there's a radius, and we have the set of all points the same distance from that center, but now those points can go in all directions. So I now have a three-dimensional object. The formula for the surface area of a sphere is 4 times pi r squared. If I'm asked to find the surface area of a sphere with a radius of 7, I would simply substitute 7 for r. So I would find surface area equals 4 times pi times 7 squared. That's going to be 4 times 49 times pi, which will equal 615.8 units squared. And again, surface area, like area, will always be units squared. The volume takes us from a two-dimensional surface area to a three-dimensional space. So notice that while surface area includes the radius squared, the volume includes the radius cubed. The volume of a sphere is 4/3 times pi times r cubed. To find the volume of a sphere with a radius of 7, I'm going to substitute 7 for r once again, and I would get the volume equals 4/3 times pi times 7 cubed. I myself would do that as 4 times pi times 7 cubed, all divided by 3. And when I simplify, I will find that the volume equals 1,436 units cubed. Keep in mind, volume is always units cubed.
Oops!